Now we will continue by proving that the dot product of A cross B with C cross D is A dot C B dot D minus A dot D B dot C. So that's part C of this problem. So let's write in part C the dot product of A cross B and C cross D using subscript summation notation. This implies that we're taking the kth component of the first vector, which is A cross B, multiplying it with the kth component of the second vector, which is C cross D, and adding over K, where K can take values 1, 2, 3, for example. And now I have to recall how do I write the kth component of a cross product. This is epsilon ijk ai bj. That's the kth component. If it wasn't the kth component, I would have ek hat here, but it's the kth component, so it's just the pre-multiplier. And for C cross D, I have epsilon lmk cl dm. Right. So that's how I write it. Now, this is equal to A sub I, B sub j, C sub l, D sub m. I will put the epsilons together. Epsilon ijk, epsilon lm k. Now notice that k's are in the same spot here as the last index in the Levi-Civita symbol. Now I can use the Levi-Civita identity. So this is A sub I, B sub j, C sub l, D sub m. Kronecker delta first indices IL. Kronecker delta second indices Jm minus Kronecker delta inner indices JL and outer indices Kronecker delta IM. So that's the Levi-Civita identity that I'm using. Now this indicates that L's will be replaced by I and M's will be replaced by J. So let's first do that. This is equal to A sub I. I had C sub L, that becomes C sub I because L is replaced by I, and then M is replaced by J. I had B sub J, that remains, but D becomes D sub J. So that's the first term here. Minus, then I have to put a minus sign. Then I have the second term, which says M's will be replaced by I, so this will be AI DI, and L's will be replaced by J, BJ, CJ. So minus AI DI, BJ, and CJ. Okay. So what does that correspond to? So if you write it like this, you can see if you put the parentheses here, you can see that what I have inside the parentheses are nothing but dot products. So this is basically corresponding to the following dot product, A dot C AICI multiplied with BJ/DJ, that's B dot D, and then we have minus AIDI, A dot product with D, and then we have B dot product with C. Okay, therefore, so we conclude that A cross B dot product with C cross D is equal to A dot product with C, B dot product with D minus A dot product with D, B dot product with C. So which was the suggested identity, vector identity. Let's go back. A dot C, B dot D minus A dot D, B dot C. Let's move on to part D of the problem. A cross B cross product with C cross D is A cross B dot product with D times vector C minus A cross B dot product with C multiplied by vector D. So let's prove this identity. This is the last example, last exercise. Okay, now we're going to consider A cross B cross product with C cross D. Okay, and in subscript summation notation, this is written as epsilon ijk, the ith component of A cross B vector, jth component of C cross D vector in ek hat direction. Okay, now this is equivalent to ith component of A cross B vector, and then I have C cross D's jth component, that is epsilon M and J C M D N. So I have taken the jth component. Then I have epsilon ijk ek hat. And now I'm going to replace ijk with ikj. So let's see, epsilon ijk is equal to minus epsilon ikj, because I have one switch of indices, consecutive indices. Then there's an odd number of switches, which is giving me a factor -1 I have to include. So this tells me that I have here A cross B's ith component, Cm Dn, epsilon M and J, epsilon ikj with a minus sign ek hat. Okay, so that means we have A cross B's ith component multiplied with Cm Dn. Now I'm using the Levi-Civita identity. First delta Mi, seconds delta Nk. Delta Mi, delta Nk minus inners delta Ni, delta Mk. but I have a minus sign, so this is there's a minus sign here. So this is going to be plus, this is going to be minus. Okay. Now if I operate that Kronecker delta to the left hand side, I have A cross B ith component. This is telling me that n's will be replaced with I and m's will be replaced by k. So this is ek hat. So A cross B's ith component, D sub I C sub k minus A cross B's ith component, m's will be replaced by I, C sub I, D sub k, and this is all in ek hat. Now you can see that we have here A cross B's ith component, D sub I, ck, ek hat. So going back to vector notation here, this implies I'm taking the dot product of A cross B with the vector D, multiplying it with vector C, ck, ek hat, that's vector C, and minus, here I'm taking the dot product of A cross B with vector C, multiplying it with dk ek hat, which is vector D. So finally, we have proven that, so we can say this, A cross B cross product with C cross D is equivalent to A cross B dot product with vector D multiplied by vector C minus A cross B dot product with vector C multiplied by vector D. So that's the identity we were trying to prove. Okay. So just to double check, that's our correct answer. So in part C, we worked on the dot product between two cross products. That means you have to take the same component of the two vectors and add them up. So A cross B is kth component multiplied by C cross D is kth component. How do you write kth component of a cross product? Epsilon ijk, ai bj. If you put ek hat, that's the cross product, but we are taking the kth component, so we just consider the pre-multiplier. Similarly, epsilon lmk, cl dm. Epsilon ijk, epsilon lmk, we can use the Lewis-Civita identity, Kronecker delta firsts, il, seconds, jm, minus inners, jl, outers, im. Then this sets L is equal to I, AI, CI, and this sets M is equal to J, BJ, DJ. So that means we will have A dot C and B dot D, AI, BI, AI, CI, BJ, DJ. Minus this sets J is equal to L, BL, CL. So dot product between B and C and dot product between A and D. So that's what we have in our final answer. Now A cross B cross C cross D. So that means we're talking about a vector here, epsilon ijk, ith component of first vector, jth component of second vector in ek hat direction. So I leave this one alone. I work on C cross D's jth component, which is epsilon m and j, cm, dn. Normally there would be an ej hat here, but I'm taking the jth component. So epsilon m and j and epsilon ijk, we can't use the Lewis-Civita identity. J has to be in the same place. So k and j switch places. Odd number of switches, we have to include a minus 1 here. So this is Kronecker delta firsts, seconds, mi and k minus inners, ni, mk, outers. But because of the minus sign, we put this one minus, this is plus in EK hat direction. And this says M is I. So A cross B is ith component multiplied by, this says N is I, DI, and M is K, CK, minus, for this one we have M is I, A cross B, I, CI, and N is K, DK, EK hat. So DK, EK hat is vector D, CK, EK hat is vector C, and here I have A cross B dot product with D, and here I have A cross B dot product with C, which is the answer I was looking for.